So the first task for Math 2 Module 1 talks about a new type of function. It introduces it in this Develop Understanding task. It says, cell phones often indicate the strength of a phone signal with a series of bars. The logo shows how this might look for various levels of service. Okay, so you have Figure 1, Figure 2, Figure 3, and Figure 4. So with this, it says, assuming the pattern continues, draw the next figure in the sequence. Okay, now the best way to look at this is, right, Figure 1 was a 1 by 1. Figure 2 was 2 by 2. Then 3 by 3, and so on. So when I go to do this next one, right, I know I'm going to have 5 blocks on the bottom, and I know I'm going to have 5 going up. And now I'm just going to fill these in. Okay. So when I look at it, right, it's asking how many blocks would there be in Figure 10. Okay. Now, when I look at that, that makes it tough, right? Because it's a tougher pattern to go through. So let's go over and take a look at it. I want you to guess how many blocks you think there would be in Figure 10, or strategically try to find it. Okay, now if I start making a table here, right, x, f of x, right, in Figure 1 I had 1 block, in Figure 2 I had 3 blocks, Figure 3 I had what, 3, 5, 6 blocks, and then Figure 4, 4, 7, 9, 10 blocks. If I look at this pattern, right, if I notice here, that goes up 2, then up 3. So it's not arithmetic. But if I multiply this by 3, 3 times 3 would be 9. It's not geometric either, right? So this pattern, we cannot write an explicit rule for an arithmetic or geometric sequence. So what can we do? Okay. Now, I look at it one way. There's a couple of different ways you can do it. Some people will go through and try to draw all of these figures. Okay, that's crazy. It's going to get very chaotic. So can we mathematically try to figure this out? Well, let's do what I said here a minute ago. In Figure 1 it was a 1 by 1. In Figure 2 it was 2 by 2. So here we had 1 block. Here we had 3. Here we had 6. Here we had 10. So what can we do to figure this out? Well, here you had 2 by 2, 3 by 3, and so on, right? Now, one way to look at it is I'm going to try and take each of these figures and create a rectangle, okay? But when I do this, I want to create a rectangle using the same number of blocks I already have. So if I have 3 blocks in Figure 2, I want to use 3 figures to create the rectangle. And same over here, if I have 6 blocks, I want to use all 6 blocks, right, to duplicate and create a rectangle. So here, if I have 10 blocks, I'm going to add 1. Here's 3. Here's 6. And then if I add these 4, that would be 10. So doubling the number of blocks gives me a rectangle, right? Now, what you can notice from this is, how many blocks do I have here now? 6. How many do I have here now? 12. How many do I have here now? 20, right? So with this, right, if I double the number of rectangles, or number of boxes, they give me rectangles. So how could I find the area of the next one? Well, if I know the next one, right, is going to be figure 5, what would the base of this rectangle be, and what would the height of this rectangle be? Well, if I look at all of these, right, the height of all of these is equal to the figure number. Height of 2, height of 3, height of 4. So what would the height of the fifth figure be? That would be 5. Now, the bottom part here, what is it here? This would be 3, this would be 4, this would be 5. 1, 2, 3, 4, 5, right? So down here, how many boxes would there be down here? 6. Now look here. 3 times 2 is 6. Didn't I get that number there? 4 times 3 is 12. 5 times 4 is 20. So if I look here, can I take the figure number, then multiply it by the figure number plus 1, but then what do I have to do to it? Divide by 2, right? Because I only want half of what I have. So if I'm looking for figure 10, 10 times 10 plus 1, all divided by 2, would give me 110 divided by 2, which is 55. So I know it's hard for some of us to possibly think to approach the problem like this, but realistically, when you look at it, hopefully like the way I showed it helps make sense. So the reason this is important to kind of understand, because it really helps us with the part 3. Okay, examine the sequence of figures and find a rule or formula for the number of tiles in any figure number, right? So when I look here, it kind of is using what we did here. And we're actually going to call this an explicit rule, where we say, and I'm going to use f of x, equals, if x is my input, figure 1, figure 2, 3, 4, that's going to be x times the figure number plus 1 would be x plus 1, all divided by 2. So if I wanted to find any figure beyond that, I could use that rule. Now, I want you guys to see if you can come up with a potential, right? A potential second rule, a recursive rule. Okay? If you don't understand this, isn't the end of the world. But when I look at it, right, when we go to talk about this new type of function, I want you guys to consider trying to look at the pattern to see something. Okay? So, pause the video and come back and try and give me the recursive. So we know we're going to start with f of 1 equals 1. But then f of x is equal to, right, in this case, what are we doing to the previous term? So if I look here, I added 2, I added 3, I added 4. Didn't I basically just take the previous term and add the new amount? 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So couldn't I just say this would be f of x minus 1 plus whatever x is, right? So if x is 1 plus, or if x is 2, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So this recursive rule would also work as a rule. Now, obviously, again, this is not arithmetic or geometric, but it's going to present a new type of function. Go ahead, try the homework, and go from there.